Welcome back to AS Mathematics. Today's session we will be starting AS Mathematics chapter 5. You know, like last time in chapter 4 we divided the chapter into 3. Here chapter 5 is divided into 3 areas: session 1, session 2, session 3. Today's session 1, we are doing straight lines, and you are given an assignment number in your assignment. Once you finish your multimedia channel ASM PM5V1, you have to refer the relevant assignment. So at the beginning of the chapter 5 I have given you outline. Whenever there is a session completed, you have to complete the assignment. Anyhow, it's given. Let's start. Today all about straight lines. In straight lines, we identify first upon the coordinates of 2 points. Once you identify the coordinates of the 2 points of the straight line, let's talk about x1, y1, x2, y2 as given in the display. Once we know the coordinates of 2 ends, we are able to find the gradient. So in order to find the gradient, y2 minus y1 upon x2 minus x1. So gradient of a straight line. What's the gradient of a straight line? The gradient, in the sense, it's the slope of the straight line. Here we are showing a positive gradient. In this graph we are showing a negative gradient. If the gradient you get the positive plus, in this case you will get a negative gradient. Let's focus on this. There are 2 points given: 5 minus 7 upon 4 minus 2. We can find the gradient of this line. That gives you minus 1 upon 3. It shows a negative gradient. If the gradient is 0, you are horizontal, there is no slope. Once you find the gradient, the straight line can be, the equation can put it into this format: y equal mx plus c. This is one of the format of a straight line. A straight line can put it in 2 format: y equal mx plus c or ax plus by plus c. Here the coefficients of the x and the coefficient of the y and the constant is given. In this format the gradient is very visible: y equal mx plus c. How do you convert this format? If you have a straight line on this format, it should be possible for you to convert it to the other format. Let's do some exercise on different formats. Here the A part says the gradient is minus 3. How do you identify? Y equal mx plus c. The m gradient is minus 3, it's indicated. We found the gradient is minus 3. In the case of B, in this problem we have to rearrange. If we want to find the gradient of this straight line, we have to rearrange. X minus 3y plus 5. We have to rearrange this format to y equal mx plus c. Once we change it to y equal mx plus c, our gradient is visible. So we are able to find the gradient of the equation. And the interception also, it is possible to identify the c constant. We call it the intercept. Let's do another example. The straight line L passes through we are given 2 points. One is the straight line L passes through A and 4. The other point is 3A and 3. Once we know the 2 points the straight line passes through, it's possible for us to calculate the gradient of that particular line. You can see 3 minus 4. In the early example I said y2 minus y1, that's equal to 3 minus 4 and 3a minus a. Once you simplify, you will get the gradient, that is minus 1 upon 6. Show that the line equation ax plus by plus c is equal to 0. Suppose if you have a format in this form, students should be able to identify the gradient and the y-intercept. This is another example how you work out. Ax plus by plus c equal to 0. Y is equal to so we have rearranged into y equal mx plus c, where gradient is identified as minus a upon b, and the intercept also identified as minus C upon D. Yes, we'll go for another example. Here what we are saying, two straight lines that intercept each other. When two straight lines intercept each other, the point of intersection of two lines can be found using simultaneous equation. Suppose if we have two lines, this is the intersection point. The coordinate of the intersection point can be done by using simultaneous equation. We have studied in our past chapters. So here we use the substitutional method, where y is equal to 4x minus 7. We substitute that y minus 4x minus 7 instead of this x. Where we found the coordinate x is 3 and y is 5. X is equal to 3 and y is equal to 5. So that the intersection point is 3 and 5. We are able to calculate the gradient too. We identified the gradient as minus 1, 3 upon 5. Now to construct the equation which passes through a and b, it is very easy to construct the equation. Here, y minus y equal to gradient x minus x. What we do, we just use one of the points to identify the equation such that the equation is formed. Let's do another good example. The line that passes through the points, there are 2 points given, but it cuts x is at, it cut x at a point P. Find the equation of a straight line coordinating when x axis, when it cuts x axis, the y is 0. So we can find the value of the gradient is upon so you get the answer minus 1. The gradient of the line here we are dealing is minus 1. Once we know the gradient, we can work out the coordinate of point. Let's see the example 9. Show that the point A, B and C can be joined by a straight line. The question number 9, there are 3 points. To to determine whether these A, B and C lie on a straight line, what is the mathematical proof we have to say? We have to find the gradient of AB first, and then we have to find the gradient of BC. If the gradients are same, if the slope is same, we can prove that A, B and C on a straight line. Okay, we will do another example here. Question number 11. Like the previous example, the line Y and a y equal 3 upon 2x minus 4 there are two equations. How do you find the intersection point? The intersection points, two lines can be found by using simultaneous equation. It cut the x-axis at a point P. The line y equal to x meet the x-axis at a point P. The line meet the y-axis at a point Q. Find the equation of the line joining P and Q. This is the line that connect P and Q. First of all, we have to find the coordinate of Q, and then you have to find the coordinate of P. To find the coordinate of Q, what you have to say, when x is equal to 0, in this case y is equal to minus 4. This is Q. To find the coordinates of P, when y is equal to 0, x is equal to that is y equal to 0, x is equal to 3. So we have identified the coordinates of P and Q. Find the equation of the line passes through L and M. Find the equation of the line joining P and Q. Now once you know the coordinates, it's easy for you to find the gradient of this line. Gradient of PQ (0 minus minus 4) (3 minus minus 3). That's equal to we know the gradient is 4 upon 3. Once you know the gradient is 4 upon 3, y minus, you can take one of the coordinate. Okay, let's take this. X minus 3. So once you simplify this, you will get the equation of PQ. Now let's talk about question number 16, the line Y, and there are two lines intersect each other at a point L. The point M has coordinates minus 3 and 1. Find the equation of L and M. As I said earlier, the point of intersection of two lines can be found by using simultaneous equation. So if we have two equations, we will be able to find the point L. Students, you all can work out that. And we have another point called M, where coordinates are minus 3 and 1. So finding an equation of LM is not a problem. In our previous sum also we did the same. First we found the gradient and then we apply. Once we know the gradient, we can apply this. Here y is 1. So I'll leave it to you all to find the gradient between the point L and M as per our previous exercise. Okay students, we have come to the end of session 1, straight line graphs. Hope you understood. Stay